Hi, my name is Anna. Welcome to this journey through futuristic supply chain management, robotics, and IoT. Today, we are going to study how robotics and IoT, Internet of Things, are revolutionizing supply chain management. In this chapter, we'll explore what these technologies are, their impact on supply chains, and how they work together to create a more efficient and responsive supply chain. What is robotics and IoT? Let's start by understanding the foundational concepts of robotics and IoT in supply chain management. Robotics refers to machines designed to carry out tasks autonomously or semi-autonomously, reducing human intervention. These robots perform tasks like picking, packing, and sorting goods, which are repetitive and time-consuming. The Internet of Things, IoT, refers to the network of physical objects embedded with sensors, software, and connectivity, enabling them to collect and exchange data. Together, these technologies enable supply chains to operate more efficiently, provide real-time data, and make smarter, data-driven decisions. Evolution of robotics and IoT in supply chain. Next, we'll look at how these technologies have evolved over time. In the early stages, from the 1960s to the 1980s, industrial robots were introduced for simple tasks, like pick-and-place operations. However, these robots were limited by technology and cost. From the 1990s to 2000s, RFID and barcode systems were introduced, providing better visibility into supply chains, though robotics still operated as isolated systems. In the 2010s, with the rise of IoT and the decreased cost of sensors, the integration of robots and IoT began, creating more intelligent and interconnected systems. By 2016 and beyond, AI integration enabled learning systems and widespread IoT deployment, enabling data-driven supply chains and seamless robotics integration. Key technologies in robotics. Now, let's explore the key technologies in robotics. The first major technology is articulated robotic arms, which are used for picking, packing, palletizing, and assembly. These arms can mimic human movements, and many are now equipped with machine vision to increase accuracy. Autonomous mobile robots, AMRs, are another critical development. These robots transport materials within facilities. Using sensors and mapping technologies, AMRs can navigate and avoid obstacles dynamically, optimizing their routes. Automated guided vehicles, AGVs, follow predefined tracks within warehouses to transport heavy loads. While less flexible than AMRs, they are still reliable for repetitive transport tasks. Lastly, drones are used in warehouses for inventory counting, surveillance, and sometimes delivery, providing access to difficult-to-reach places and offering rapid oversight. Robotics in action, warehouse applications. In warehouses, robotics is having a significant impact. Applications include goods-to-person picking systems, where robots bring items to workers rather than having workers go to the items. This increases efficiency and accuracy. Automated sorting systems and automated storage and retrieval systems, ASRS, also play crucial roles in reducing human intervention. These systems can sort packages based on their destination, ensuring faster processing. Robotic palletizing and depalletizing systems further reduce labor costs while improving accuracy. Modern warehouse robots achieve up to 99.99% picking accuracy, demonstrating their efficiency and cost-effectiveness. IoT devices in supply chains. In the next section, let's talk about IoT devices used in supply chains. Environmental sensors are crucial for monitoring conditions like temperature, humidity, and shock during transportation, especially for sensitive goods such as pharmaceuticals and perishable items. Location trackers use GPS and cellular technologies to provide real-time location data for shipments. These trackers enable geofencing, ensuring that shipments remain on track. RFID systems allow for automatic tracking of inventory, which can streamline supply chain processes by eliminating the need for manual scanning. Lastly, smart cameras are used to monitor operations and detect anomalies. They help in quality verification and reduce the need for manual inspection. IoT infrastructure and connectivity. Beyond the individual devices, the infrastructure supporting IoT is critical. Connectivity technologies like low-power wide-area networks, LPWAN, 4G, 5G, Bluetooth, and Wi-Fi enable the communication of data across different supply chain operations. These networks ensure that data from IoT devices is transmitted efficiently across the system. For data management, IoT supply chains leverage edge computing for real-time decision-making and cloud platforms for storing and analyzing vast amounts of data. These systems enable supply chains to become more intelligent and responsive. Integration of robotics and IoT. The true power of robotics and IoT comes from their integration. IoT sensors gather real-time data on environmental conditions and operational metrics, which is then transmitted to central systems. These systems use AI and analytics platforms to process and analyze the data, identifying patterns and optimization opportunities. Robotic systems then act on the data by adapting their operations accordingly, creating a feedback loop that enables continuous improvement and adaptive behavior in supply chain operations. Business impact, cost reduction, and efficiency. The integration of robotics and IoT offers significant business benefits. Robotics and IoT can help companies reduce labor costs by automating repetitive tasks and inventory reduction by providing real-time visibility, allowing businesses to maintain optimal stock levels. Error reduction is another key benefit, as automated systems minimize human mistakes in picking, shipping, and quality control. Finally, energy savings can be achieved by using IoT systems to monitor and optimize energy usage in facilities, further enhancing overall operational efficiency. Case study: Amazon Robotics. Amazon is one of the leading examples of robotics and IoT integration. The company operates over 350,000 mobile robots within its fulfillment centers, working alongside human workers. These robots help with tasks such as moving shelves to human pickers, managing inventory through IoT-enabled systems, and optimizing delivery routes. The impact has been profound, with order processing times dropping from 1 to 2 hours to just 15 minutes, storage capacity increasing by 40%, and operating costs reducing by 20%. Case study: Ocado's Smart Platform. Another example is Ocado, a UK-based online grocer that has developed a robotic warehousing system. This system involves a grid of over 1,000 robots and is powered by an IoT-based orchestration system that coordinates robot movements with 5mm accuracy. The result has been an impressive 50,000 orders processed daily with 99.9% accuracy, and energy consumption has been reduced by 30%. Key takeaways. As we conclude, remember the key takeaways from this chapter. Integration of robotics and IoT is vital for creating cohesive, efficient systems in supply chain operations. These technologies provide data-driven value by improving operational visibility and predictability. Thanks to more scalable solutions, what was once limited to large enterprises is now accessible to mid-sized businesses. Finally, human augmentation, not replacement, is the most successful model for using these technologies, improving capabilities without completely eliminating human jobs.